Today I'm going to implement networking on an STM32 microcontroller, specifically on this Nucleo-F746 development board with built-in Ethernet interface. As a result, this board will serve an embedded web UI with a moderately complex device dashboard with user authentication, which is able to show a real-time device data, is able to show and modify device settings, and which is able to connect to a remote MQTT server and send and receive commands from it. I will implement everything from scratch using Cube IDE development environment and Mongoose networking library. Here it is on GitHub. On step 1, we implement a simple blinky. On step 2, we implement UART output. On step 3, we implement printf debug output by redirecting printf to the UART. On step 4, we change system clock. On step 5, we enable Ethernet. On step 6, we integrate Mongoose library. On step 7, we implement a simple web server using Mongoose. And on step 8, we implement a full device dashboard. So let's start. Open Cube IDE environment and click on Create New STM32 project. In part selector, type F746ZG, select this microcontroller and click Next. Choose a name for the project, F746ZG, click Finish. We are on step 1, which is implementing a simple blinky. This development board has 3 onboard LEDs, green, blue, and red. We are going to blink a blue LED, which is connected to port B, port 7. So let's search for PB7 pin. It's here, click on it and choose GPIO output. Now click on Build Project. Cube IDE generates code, and now the project is built. Let's make an LED blink. So in the super loop, let's toggle LED, HAL, GPIO, toggle pin, GPIO B, and pin 7, GPIO pin 7. And let's wait for half a second. HAL delay 500 milliseconds. Save, click on build again. So we see that firmware builds fine. Now let's flash it. Click on this green button to flash it. Click OK. So this board has a built-in debugger, and we flash it through this built-in debugger, so we see the blue LED starts blinking. Let's move to step number 2, which is implement UART output. And the pins are PD8 and PD9. So let's click on PD9 and choose UART 3RX. Click on PD8, choose UART 3TX. And here choose connectivity, UART 3, and choose mode asynchronous. Okay, click on build project. So the project builds again successfully. And let's add the UART output here. HAL UART transmit. So UART 3, and let's say transmit message hi. Hi, 4 bytes, and timeout 500 milliseconds. Okay, let's flash it to the board. Let's observe the UART output. I'm on Mac OS, so there is a built-in tool, CU, that is able to attach to the serial port. So CU-L, this is the port name. On your system it could be different, and minus speed 115200. So click enter. So we see the high output. So that means our UART code is working. Let's move to the step number 3. On this step, we redirect printf to the UART, open src syscalls.c, and search for the right function. So here we comment out everything. If file equals 1, then we do how UART transmit extern HUR3, so HUR3 data is PTR, size is length, and timeout, let's say it's 1 second. Okay, and let's include main.h. Okay, rebuild. So in the main loop, let's change the UART transmit to printf. Let's change the message high 2 and reflash the board. And now we see that the UART output changed to high 2. So that means that we redirected printf calls to the UART. So from now on, we can use a printf for the debug output. Step number 4, change system clock. By default, this board runs on the 16 megahertz, but it is able to run on 216 megahertz. So let's open system clock configuration. Let's change 16 to 216. Click enter to automatically select settings. So click rebuild. So the board continues blinking, and now our board runs on maximum speed of 216 megahertz. Let's move to step number 5, which is enabling Ethernet. Open configuration. Select system core, sys, and choose time-based source to timer 6. Then go to connectivity Ethernet and choose RMII mode. Here in the settings, click on Enable Global Interrupt. So click here. And on GPIO settings, Cube has some settings wrong. So we can consult a document called UM1974, which is a documentation for Nucleo-144 boards. Open paragraph 6.10, which lists Ethernet pinout. We need to change settings for 2 pins, PG11 and PG13. So let's go to the Cube IDE and find pins PG11, set ETH-TX enable, and PG13, ETH-TX D0. So, all right, so now our Ethernet settings should be correct. Click to rebuild the project. Okay, so the project rebuilds fine, and we still see our LED blinking. So let's move to the step number 6, which is integrate Mongoose library. Mongoose library is an open source project on GitHub, so go to github.com/mongoose. To integrate Mongoose, we just need to copy two files, mongoose.c and mongoose.h, to our project. Open core include, and here we do new header file, name it mongoose.h. So that's the new file, and let's click on mongoose.h on the repository, click on raw, and let's just copy paste the contents in here. Okay, so we moved mongoose.h, and in src let's add mongoose.c. Click on source file, name it mongoose.c, and download mongoose.c file, copy and paste it, save. Now in main.c, let's include mongoose.h. So when we build, so click on build the project, and we see that it shows an error. It cannot find a mongoose.custom.h. So this is a Mongoose configuration file. So let's add mongoose custom.h, and in this file we should specify environment we are running in. So define mg arch to mg arch new lib. Click on rebuild the project, and now the project builds fine. Let's move to step number 7, which is to implement a simple web server. Mongoose library is able to work in different environments, and Unix, Windows, macOS, and multiple embedded systems. It runs pretty much everywhere. It can run on any OS or real-time OS, or it can run without an OS at all. And it can use different TCP/IP stacks, but also it implements its own TCP/IP stack. And using a built-in Mongoose TCP/IP stack is the simplest way to implement networking. Type define mg enable MIP to 1 to enable a built-in Mongoose network stack. Open main.c, declare Mongoose event manager, struct mgr manager, mgr init. Next step is to initialize network stack. So we declare IP configuration. This is the MAC address. We just choose some arbitrary MAC address. We set IP, mask, and gateway to 0 to enable DHCP. And we call MIP init function with this IP configuration, and we use STM32 driver. And then in infinite loop, we call mgr poll. Click on reflash. We have an error which says that Ethernet IRQ handler is defined more than once. So, and this is right because a Mongoose IP stack uses its own implementation of the Ethernet handler, which conflicts with the default predefined. So let's just disable a generated IRQ handler. Let's just rename it, so append letter X. And there is one more thing we need to do, is to enable custom millis, just to make sure that the timers in Mongoose work correctly. So mg enable custom millis equals 1 in mongoose.custom. Click on build, and we see there is an error saying that mg millis is not implemented, so we have to implement mg millis. UN64T mg millis, and here we just return hell get tick. That's it, that should be it. Let's refresh the firmware. It refreshes okay. Now you see that the LED blinking has stopped. And that is because our new loop makes this blinking loop unreachable. But we see a message from the TCP IP stack saying that the IP is ready. So let's try to ping that IP. Okay, so it pings. That means networking works okay. So now let's implement a very simple web server. So we do mg http listen manager. Let's use http000 as the listening URI. Let's use event handler function fn and pass mgr as the parameter. So now we have to implement the event handler. This event handler implements a very simple web server which responds okay to any HTTP request. So no matter which headers, method, which URI, it always responds with okay. Let's flash this firmware. Let's open a new browser window, 192.168.2.10, and we see the message OK. So that means that we are running a very primitive web server successfully. So now we can enhance it by changing this event handler function. We can act differently on different URIs. We can respond with RESTful data and so on and so forth. So let's move to step number 8, which is implementing a full device dashboard. Switch back to the browser and open the Mongoose repository. Click on Examples, Device Dashboard. We are going to copy 2 files from this example, a net.c file, which implements an event handler function, MQTT functionality, and so on. And another file is spect.fs, which is a web UI data packed into a C file. So I will not go into details explaining how this works, because there is a detailed tutorial on mongoose.ws website. If you go to developers tutorials, there is a web UI section which explains every part of the UI, the logging, the real-time data push, embedded file system, and so on and so forth. So click on net.c, click on raw, and copy it. And let's move it to source. So click new, source file, net.c, and paste it, save. And the next file we're going to copy is spect_fs.c. Copy it and paste it here, spect_fs.c. Okay, and what we are going to do, we are going to use an event handler function from this file, a function called device dashboard fn. So go to main, And here in our MG HTTP listen call, just change fn to device dashboard fn. So first we declare it, extern void device dashboard fn, and then let's substitute fn to the device dashboard fn, and click on reflash. Okay, it didn't work because undefined reference to make there. Okay, so let's disable POSIX file support. Click on Mongoose custom.h, define mg enable file 0, and click on reflash again. Oh, we have to enable packed file system support. So define mg enable packed fs to 1. Okay, click on rebuild again. Okay, now it works fine. Okay, so open the UI again, and we see that the dashboard is working. Let's log in as admin, username admin, password pass0, click return, and we see that real-time data is coming through, that the MQTT server is connected. Let's send some message, hello. And we see that the response came back, and we see some more messages because we are using a public MQTT server, so anybody can send messages. So somebody tried our example before and used retained messages. So we have implemented a real-time device dashboard with MQTT functionality on the Nucleo-F7 development board.